One AI agent makes a bad decision. In isolation, the damage may stay small, but connected agents can copy, trust, and amplify it. A planner delegates the error to several specialists. Those specialists call tools and update shared state. Retries can multiply the same action again. Soon the original mistake is no longer the main problem. The security issue is how far it traveled. This is an agentic cascading failure. OWASP separates the trigger from the propagation. The trigger might be a hallucination or malicious input. It could be poisoned memory or a corrupted tool. A spoofed message might start the same chain. Those defects already belong to other risk categories. The cascade begins when the fault crosses boundaries. It spreads into new agents, sessions, or systems. Each handoff can increase authority and consequence. Containment must focus on stopping that amplification. Imagine an agent reviewing routine service alerts. It incorrectly labels one warning as a major incident. A planning agent trusts that label without validation. It dispatches tasks to networking and support agents. Automation starts pausing healthy internal services. More alerts appear because those services are interrupted. The planner interprets the new alerts as confirmation. Retries and parallel tasks widen the disruption. One false signal became a self-reinforcing event. Multi-agent systems create several paths for amplification. One output can fan out to many recipients. Downstream agents may inherit trust from the sender. Shared memory can preserve the faulty conclusion. Broad credentials can increase the impact at each hop. Parallel execution can outrun human intervention. Automatic retries can create duplicate actions and queue storms. Feedback loops can make agents validate each other. Connectivity turns local uncertainty into systemic risk. An internal agent message is still an input. Verify the sender, recipient, type, and freshness. Bind every message to one workflow and user goal. Use strict schemas for facts evidence and requested actions. Keep confidence separate from verified evidence. Mark content derived from external or untrusted sources. Reject fields the receiving agent does not need. Never inherit privileges through the message itself. Trust must be earned again at every boundary. Do not pass raw model output directly downstream. Check that the response matches the expected schema. Verify reference records against authoritative systems. Compare the proposed action with the original goal. Reject malformed low confidence or off-topic results. Require stronger evidence as consequence increases. Use deterministic rules for hard safety limits. Pause the workflow when validation cannot decide safely. A stopped workflow is better than a confident cascade. A planner should propose steps, not authorize them. Execution should sit behind an independent policy layer. That layer checks identity, scope, parameters, and risk. It should not trust the planner's explanation alone. High-impact actions need a preview or approval gate. Parameter changes must trigger a fresh decision. One agent should not create and approve its own exception. Keep enforcement outside the language model. Corrupt planning must not become automatic execution. Design every agent with a maximum consequence. Limit how many tasks it can create per run. Limit records, systems, and tenants it can affect. Use short-lived credentials scoped to one task. Restrict which agents may contact each other. Segment networks, tools, memory, and execution environments. Require escalation before crossing a risk boundary. Keep safe rollback paths for reversible operations. Small blast radius caps turn catastrophe into interruption. Retries help only when a failure is temporary. Unbounded retries repeat faults and consume capacity. Give each workflow a strict retry budget. Use exponential backoff and random delay where appropriate. Deduplicate repeated intents before they reach tools. Open a circuit breaker after a defined threshold. Fail quickly while the dependency or workflow recovers. Allow only limited probes before restoring full traffic. Recovery logic must not recreate the original storm. Shared mutable state can carry errors across agents. Store the minimum state each role requires. Separate tentative conclusions from verified facts. Version important state instead of silently overriding it. Record which agent produced every update. Do not reuse broad credentials across the entire workflow. Revoke task credentials when the run ends or fails. Quarantine suspicious memory before future sessions loaded. Persistence should support recovery, not preserve compromise. Every tool action needs a unique operation identifier. Idempotency prevents the same request from executing twice. Deduplication stops repeated messages from multiplying work. Set queue depth, concurrency, and fan-out limits. Route failed events to a controlled review queue. Do not replay them automatically without updated evidence. Preserve ordering when later actions depend on earlier state. Compensating actions should be explicit and tested. Safe delivery means controlling every side effect. Local logs are not enough for a distributed failure. Trace every handoff across agents, tools, and policies. Record sender identity, message lineage, and workflow scope. Capture validation decisions and execution outcomes. Monitor rapid fan, out and cross domain spread. Alert on retry loops and repeated identical intents. Queue growth, privilege use, and unusual tool volume. Use tamper evident timestamps for forensic reconstruction. You cannot contain a cascade you cannot see. Do not wait for production to discover propagation paths. Simulate agent failures in an isolated environment. Inject malformed outputs, timeouts, and duplicate events. Test what happens when shared services become unavailable. Confirm circuit breakers open at the expected threshold. Verify degraded modes remain useful and safe. Replay recorded workflows against blast radius limits. Practice rollback, credential revocation, and state quarantine. Recovery evidence should be part of every release gate. Assume one agent will eventually be wrong. Validate every handoff before trusting its output. Separate planning, policy, and execution authority. Cap fan out retries privileges and affected resources. Use circuit breakers, idempotency, and safe degraded modes. Trace action lineage across the complete workflow. Test containment and recovery before production deployment. If you are finding this content useful, please subscribe, like, and comment. Build agent systems where one failure stays one failure.